The distinction between structural and reduced form models is crucial for understanding the relationships between economic variables and for conducting meaningful analysis, especially concerning causality and policy implications. Here's a more detailed look within the econometric context. Structural model in econometrics. Focus. A structural model in econometrics aims to represent the underlying economic theory that is believed to generate the observed data. It specifies the direct causal relationships between economic variables based on theoretical assumptions. Simultaneous equations often involves a system of simultaneous equations where endogenous variables determined within the model, are jointly determined. This recognizes the interdependence that exists in many economic phenomena. Parameters. The parameters in a structural model are intended to have a direct economic interpretation, reflecting behavioral responses, technological constraints, or institutional rules. Identification. A key challenge with structural models, especially simultaneous equation systems, is the identification problem. This refers to the difficulty of uniquely estimating the structural parameters from the observed data. For identification, we often need exclusion restrictions, variables that affect one equation but not others, or other forms of identifying assumptions. Policy analysis. Structural models are particularly valuable for policy analysis because if the underlying structure is correctly specified, the estimated parameters should be policy invariant. This means that these parameters are expected to remain stable even if government policies or other exogenous factors change, allowing for predictions of the effects of such changes. Example. A classic example is a supply and demand model, begin aligned. Q_D and equals alpha, _0 plus alpha, _1p plus alpha, _2y plus u_d quad text demand equation. Q_S equals beta _0 plus beta _1p plus beta _2w plus u_s quad text supply equation. Q_D equals Q_S equals Q quad text market clearing condition end aligned. Here, Q quantity and P price are endogenous, determined within the model. Y income and W wage are exogenous variables. The coefficients alpha_1 and beta_1 represent the price elasticity of demand and supply, respectively, and have direct economic meaning. Estimating these structural parameters requires addressing the endogeneity of price and quantity. Reduced form model in econometrics. Focus. A reduced form model expresses each endogenous variable in the system solely as a function of the exogenous variables and the error terms. It does not directly represent the underlying economic theory or the causal mechanisms. Direct relationship. It describes the overall relationship between the exogenous variables and each endogenous variable without detailing the channels through which the effects operate. Parameters. The parameters in a reduced form model are typically a mix of the underlying structural parameters and do not usually have a direct, straightforward economic interpretation on their own. Estimation. Reduced form equations can usually be estimated using single equation methods like ordinary least squares (OLS) because the right-hand side variables are exogenous, by definition in the reduced form. Prediction. Reduced form models can be useful for forecasting and for examining the overall impact of exogenous variables on endogenous variables. Limitations for policy. Because the parameters of a reduced form model are often a function of the underlying structural parameters, they may not be stable if the economic structure or policies change. This is the essence of the Lucas critique. Therefore, using reduced form models for policy analysis can be misleading if the policy change alters the fundamental relationships in the economy. Derivation. The reduced form is derived algebraically by solving the system of structural equations for each endogenous variable in terms of the exogenous variables. Example from the supply and demand model. To get the reduced form, we solve the demand and supply equations for the endogenous variables P and Q in terms of the exogenous variables Y and W and the error terms. Begin aligned. P and equations phi endogenous cr 0 plus phi endogenous cr t. 1y plus phi endogenous cr t, and equations 1q, and equations gamma endogenous T, endogenous curve 1y plus gamma endogenous T, 2w plus variations von y endogenous T, underlined. Here, the p and gamma coefficients are combinations of the alpha and beta structural parameters, and v_1 and v_2 are combinations of the structural error terms. Estimating these reduced form equations can tell us how income and wages affect price and quantity, but the coefficients themselves don't directly represent elasticities. Key differences summarized for econometrics. Feature: structural model, reduced form model, goal: represent underlying economic theory and causality. Describe the overall relationship between variables. Equations: often a system of simultaneous equations, each endogenous variable as a function of exogenous variables. Parameters: economically interpretable, e.g., elasticities. Combinations of structural parameters, less direct meaning. Endogeneity: explicitly models and addresses endogeneity. By construction, right-hand side variables are exogenous. Identification: crucial issue. Requires identifying restrictions. Generally not an issue for estimation. Policy analysis: ideally suited if structure is stable. Policy invariant parameters can be misleading if policy changes the underlying structure. Lucas critique: estimation requires methods for simultaneous equations, e.g., 2SLS, 3SLS, can often be estimated using single equation methods, OLS. Focus: understanding why, understanding what is the overall relationship. In practice, econometricians often work with both structural and reduced form models. Structural models provide deeper insights into economic behavior and are essential for reliable policy analysis, but they require careful theoretical specification and addressing identification challenges. Reduced form models can be useful for forecasting and describing data patterns, but their interpretation regarding underlying mechanisms and policy implications needs caution.